Hello everyone, and thank you for attending this presentation. Today, I will talk about applying artificial intelligence tools such as LLMs and vision models to tabular datasets. We have touched upon this topic in our earlier presentations, and therefore, before delving into the details of this presentation, I would like to provide a brief overview of what we have done before, and this will give us some background and context for our discussions today. Why image models? Well, images are all around us. We human beings start out our lives by processing images and objects around us and become exceptionally good at it. And we end up classifying objects every day without really thinking too much about it. This is round and rubbery, so it's a ball. This object has four legs and a flat surface, so it's a table. Here is a glass of water, and that is a pen. And here is my computer. So we are really good at looking at features of images and objects and identifying what they are. Learning to understand words only come later once we learn to recognize alphabets. So our brains are wired to get a lot of information from an image, and we have all heard the saying that a picture is worth 1,000 words. Since neural network models are inspired by the structure and function of the human brain, it makes sense that neural networks would also be very good at image classification. In fact, in recent years, image classification has seen major advancements, with deep learning models sometimes achieving above human level performance in object detection and recognition. This has been possible due to convolutional neural networks, which are a type of deep learning neural networks particularly well suited for analyzing visual data like images and videos. CNNs can effectively extract information from images through convolution operations. They excel at extracting spatial and hierarchical features as well as feature interactions from images. So now that we have a neural network that excels at extracting features from images, can we utilize it to enhance our predictive models? The challenge is that our data is a tabular data set, and tabular data lacks the spatial structure that CNNs require to operate effectively. In order to use the power of CNNs, we need images. So the next challenge is to convert this high-dimensional tabular data set to images. There are many ways in which this can be done, even when we have a tabular data set with large number of rows and columns. Let me digress here for a few moments to talk about the dataset that we have been working with in all of our experiments, including the current ones. We have been working with the Australian credit risk dataset, which contains approximately 14 attributes, some of which are numerical and some are categorical. The attributes were masked, and we have a binary dependent variable which identifies the defaulters. As before, all models were built to regulatory standards, so we dropped variables from our models if they were too highly correlated with the dependent or with any other independent variable. On this slide, we present a summary of the key findings from all of our experiments. In our previous webinar, we performed the first experiment by directly giving a prompt to the llama model. We found that its predictions were not significantly better than those of a random guess. The traditional logistic regression model performed much better than the llama model, as shown in the second row of this table here. At that time, we were also able to extract embeddings from the llama model, and when we used those embeddings as additional features in our logistic regression model, the AUCs went up significantly. We also tried to fine-tune a more specialized LLM model, which is the Finbert model, and found that such fine-tuning significantly increased our AUCs. So the top performing models for our earlier experiments were the fine-tuned LLM, which is shown on the fourth row, and the traditional plus embeddings logistic model, which is shown on the third row in this table. Today, we have talked a lot about image models, and some of the results from our top image models are now shown on this slide. Upon inspecting these results, we find that they look even better. So our top performing image models outperform the LLM models we tried in our earlier experiments with the same dataset. We are, of course, still experimenting with both LLM models and image models, and work in this area is ever changing as new LLMs are being developed regularly, as well as different techniques for creating images. Obviously, many more experiments must be performed with many other datasets to see if these results hold in general, but for now, it seems that a picture is indeed worth 1,000 words. Next, I will hand it over to Krishna, and he will talk about some of the business implications.
Thank you, Pat, for indeed showing us that uh, image is worth 1,000 words. So, while this is very interesting, a, a question that comes to mind is why should a lending organization care about it? How does this impact their operations? So, let us start by talking about the most obvious application and the lowest hanging fruit in front of us. That is enhancing the tabular models that are already available to us. So, you know, um, to build a credit risk model, we use features or predictors which help us get to a score. And to bring the features to their maximum potential, we do what is called feature engineering, where we eh, make them interact, transform uh, them, and do various manipulations to select the right features and bring them and massage them into the right shape. So, uh, at the very least, we can take vision models as an additional tool for this exercise. Using this, we could get embeddings, mm, we could, in fact, get vision model scores or classifications, and there are lots of other ways in which our tabular data can be enhanced using vision model outputs, which will lead to a superior scorecard. And the great thing about this is that these models are fairly easy to implement within the local environment. So what that means is that data is not exposed to the cloud, and a lot of data privacy and security concerns are taken care of. And because of that, this becomes a very practical business innovation, almost a first step, if you will, where you can deploy vision models within your environment and use them to enhance your already existing credit risk scorecards. Another way in which organizations can use vision model is by actually using the images in their credit risk process and building multimodal models that use both the image and the traditional tabular data. So in doing so, uh, this could be, for example, for consumers, it could be their houses, or if we are doing B2B, these could be the offices, or if we are doing equipment finance, it could be the equipment against which the loan is being issued. In all these cases, this additional data will improve the model's accuracy. But the accuracy is not the only thing we are gaining here. We are introducing a new data source, a diverse data source, and in doing so, we are complementing the financial metrics. And because of that, our model will become more robust and stable, and we will have greater confidence in the applicant's creditworthiness. We are doing some experiments on this, and our initial findings are very encouraging. We will be hosting a webinar on this topic in December, and we look forward to having you there. We have till now talked about the approval process for a credit applications. But what about after the loan has been granted and funded? At this point, we still want to monitor our lendees to make sure we do not have a risk of default. Um, so, traditional approach here is to look for mispayments or signs of distress like uh, drop in scores, all of which is essential and excellent measure, but unfortunately, these are lagging indicators, not leading indicators of distress, and often too late. And over here, visual data provides us a big opportunity to speed up our action. For example, what if this was a retail store and we could get satellite pictures of its parking lot, say every Saturday, and we monitor it, and a sustained uh, drop in intensity of traffic there tells us something about upcoming financial distress. Or take an individual borrower, and if we could scan property images, any sign of uh, upkeep, drop in upkeep, lack of maintenance could be an indicator of upcoming financial distress. So these are just examples, but just just imagine how much additional benefit and tools an organization can get by using visual data to enhance their risk management.